Hi everyone. Today on SOP 101, we'll be showing you how to properly calibrate and use an electronic pH meter.
Before we begin, let's make sure we have all our proper safety supplies. Can you see anything that I'm missing? Oh, safety goggles. That's right.
And don't forget, since we have long hair, we have to put it back like this.
Okay, and we've all got our safety goggles, proper clothing. Looks like we're ready to begin.
Today we'll be testing the acidity of sulfuric acid, sodium hydroxide, household ammonia, and acetic acid.
So before you begin, the first thing you want to do is, depending on your pH meter, you want to turn it on, let it warm up for about 10 minutes. Luckily for you, we've already done that. Our meters just plug right into the computer, no warming up needed. So next, we're going to take our already clean pH meters and we're going to be calibrating them, a 2-point calibration with this pH 7 buffer and then this pH 4 buffer.
So first we're going to measure the pH in pH 7 buffer solution.
Make sure when you put the electrode in that the probe is completely covered. Calibrated, Lane?
Yep.
Alright. Now we have to make sure to rinse the probe with deionized water 3 times. Here goes 1,
Make sure you rinse it really good.
2, and 3.
Now we're going to measure the pH in pH 4 buffer solution.
As you can see, Ruth has properly put the probe all the way into the solution. Are we good, Blaine?
Yep, looks like we're good.
And I think you all know what we have to do now. 1, 2, 3.
Now we're going to measure the pH of sulfuric acid.
Lane, what's our reading?
Looks like negative 2.7. That's pretty acidic.
That's good, right? Because an acid is supposed to be less than 7.
Right.
So our calculations make sense.
They do.
I think you all know what we have to do next. 1, 2, 3.
We're going to measure the pH of acetic acid. The pH should read above sulfuric acid and less than 7.
Looks like we're at 2.8, so that sounds about right for a weak acid.
Now we have to make sure to clean our electrode again. Now you want to make sure that when you're cleaning the electrode, the reader goes back to about 7. So Lane, will you tell me when I'm there?
Yeah, I have a feeling it's gonna be a while though.
So sometimes you have to actually rinse it more than 3 times, but I don't think we want to count this one.
Now that we're back at pH 7, we're going to recalibrate so that we can measure the bases first and then the weak base.
Alright, now we have to clean it again. And don't forget, we have to make sure that it gets back to just about 7 on the pH meter reading. Are we good?
Looks like we're good. Go ahead and put it in the pH 10 buffer. We need this buffer so that when we're measuring our bases, we have something to go off of.
And no matter how pretty these buffers look, remember that you should never taste anything in chem lab.
Looks like we're there, so go ahead and take it out and we'll rinse it up.
Now that we're back at 7, we're going to measure our weak base, ammonia.
Again, we have to make sure that the electrode is all the way in. Looks good from this angle.
Looks like we're sitting at right about 11, so that should be correct.
That's right, because the acidity of a base should be greater than 7. To get your electrode probe back at 7, it might even be wise to get a beaker full of deionized water, like this, and stir it around a bit. That seems to help.
Okay, so now that we're back at pH 7, we're going to measure the pH of sodium hydroxide.
The pH reading for this base should be a lot bigger than the pH of ammonia because it's a stronger base. Looks good. We have a reading of 13, which is great because it's bigger than ammonia. And again, we have to clean our electrode. Well, looks like we're done here, right?
No, wait, Emily, we still have to clean and dispose of our chemicals.
All right, I guess that's the right thing to do.
That's right. And
yeah.
make sure that all of your chemicals, acidic, basic, need to go in the proper waste beakers.
And we should make sure that before we put this in the storage solution, it should be back at a pH of 7. But as you can tell before, I had already done that, so we're good to go. Finally, we're done cleaning.
Yep, everything is stored properly, as you can see, and all of our chemicals have been disposed of. Our glassware is clean.
Stored properly.
So, with that, join us next time for how to create safe explosions in the lab.
Woo!